So in this video, we're going to talk about the trigonometric identities, the double angle formulas. The first one, sine of 2 theta, double the angle, is equal to 2 sine theta times cosine theta. The cosine 2 theta double angle identity is cosine squared theta minus sine squared theta. Another version is 1 minus 2 sine squared theta, and another version is 2 cosine squared theta minus 1. Okay? So, little proof for each of these. So if I have sine alpha plus beta from the sum identities, we know that that's sine alpha cosine beta plus cosine alpha sine beta. So if I'm going to do the double angle identity, that's sine 2 theta, which equals sine of theta plus theta, which is sine theta cosine theta, plus cosine theta sine theta, which equals 2 sine theta cosine theta. Okay, so that's one of them, right? For the cosine 2 theta, so cosine alpha plus beta is equal to cosine alpha cosine beta minus sine alpha sine beta. Okay, and so cosine 2 theta equals cosine theta plus theta, which is cosine theta minus sine theta sine theta, which is cosine squared theta minus sine squared theta. So that gets us this one. Now, how do we get this one here? Well, I need to get rid of the cosine squared term. Well, what do I know? I know that this is equal to 1 minus sine squared theta from the Pythagorean identity. So how many sine squared thetas is that? That's 2 minus 2 sine squared theta from 1 there. Okay, so that takes care of this one. Now what about this last one here? Well, instead of getting rid of the cosine squared, I'll get rid of the sine squared. Okay, so this would become cosine squared theta minus, and then 1 minus cosine squared theta. And then that gets me minus a plus, gets me 2 cosine squared theta minus 1. Okay, when I simplify that, and I get it right there. So that's how we derive the double angle formulas. Let's find the exact value. Okay, so let's work through a problem. So what are we asked to do? So find exact value using double angle formula. Okay, so if I do that, so if sine theta equals 3/5, then pi over 2 to pi, find the exact value of, well, let's do sine 2 theta, okay? So what do we know? Well, sine 2 theta is 2 sine theta cosine theta. So we already know that sine theta is 3/5. We just need to figure out what cosine theta is, okay? So theta is stuck between pi over 2 and pi, so that means we're in this quadrant, second quadrant here, okay? So I'm just going to put a dot over here. Now, sine of theta, so this is theta here. Sine of theta is opposite over hypotenuse. So how do I get this side here? Okay, well, I use Pythagorean theorem. So I have 3 squared plus x squared equals 5 squared. So that's 9 plus x squared equals 25. So x squared equals 16, so x is equal to plus or minus 4. But if I'm going in the negative direction, x is negative, so this gets me x equal negative 4 because it's in the second quadrant. So cosine theta is x over r, so that's negative 4 over, what's the hypotenuse? It's 5. So negative 4 over 5. And so I need to multiply that all together. And what do I get? Well, I get 2 times 3 times 4. That gets me 624 negative over 5 times 5 is 25. Okay? So that's the first part. The second one I want to find is the cosine of 2 theta. Okay? Well, I have sine theta, and I've got several options. I can either use this equals cosine squared theta minus sine squared theta, which is easy. I mean, I already know what sine and cosine are because I've done the work from the first part. Or I can use 1 minus 2 sine squared theta, or I can use 2 cosine squared theta minus 1. I think I'm going to just use this one, because I already know that sine theta equals 3/5. So if I have cosine 2 theta equals 1 minus 2 sine squared theta, that's equal to 1 minus 2 and then sine theta all squared, right? So 1 minus 2, and then what is sine theta? Sine theta is 3/5 squared. So I get 1 minus 2 times 9 over 25. And that's what? 1 minus 18 over 25. And so 25 over 25 minus 18 over 25 gets me what? 7? 7 over 25. Okay. Now, we can do the double angle formula for tangent. And in fact, heck, we can just make this one video. That'd be okay. This video might be a little bit longer, but it'd be fine. So let's establish some more identities. Establish more identities. Okay. All right. So tangent alpha plus beta, if you'll recall, is tangent alpha plus tangent beta over 1 minus tangent alpha tangent beta. Okay? But if I do tangent 2 theta, this is tangent theta plus theta, same trick we did earlier. And so that's tangent theta plus tangent theta over 1 minus tangent theta tangent theta. So this is equal to 2 tangent theta over 1 minus tangent squared theta. Okay, so that is the double angle for tangent. Tangent 2 theta equals 2 tan theta over 1 minus tangent squared theta. Okay. Now, let's develop a formula for sine of 3 theta. Sine 3 theta, okay, in terms of sine theta and cosine theta. All right. So how would I do this? Well, I can use my double angle formula. So sine 3 theta equals sine of 2 theta plus theta, which is equal to sine 2 theta cosine theta plus cosine 2 theta sine theta. Okay. And what do I know? Well, sine 2 theta is 2 sine theta cosine theta, and then cosine theta is okay. And then plus, now cosine squared theta, I just pick one, it doesn't matter. I'm just going to go with cosine squared theta minus sine squared theta to replace. Okay. And then multiply by sine theta. So if you distribute everything out, which is fine to do, you get 2 sine theta cosine squared theta plus cosine squared theta sine theta. I distribute, right? And minus sine cubed theta. And so I have 1 here and 2 there, so that's 3 total. Okay, so that gets me 3 sine theta cosine squared theta, and then minus sine cubed theta. All right. So that's not the only way you could do it, but that is one way. Remember, you've got multiple formulas for your cosine double angle, so whichever one's valid. And all this has to do is put in terms of sine and cosine. And so there you go. Everything's in terms of sines and cosines of theta, not 2 theta or 3 theta, but in terms of theta in the argument. Okay. Rearranging the double angle formula leads to additional formulas that could be useful for you. So these are called the reduction identities. These are very important for Cal 2. So reduction identities. So how does this work? Well, if I have cosine 2 theta equals 1 minus 2 sine squared theta, if I solve this for sine squared theta, what do I need to do? I need to subtract 1 from both sides. So I have cosine 2 theta, and then minus 1 equals minus 2 sine squared theta. Okay. If I divide by negative 2, divide by negative 2, well, what's going to happen here? My first reduction identity is sine squared theta equals what? It equals 1 minus cosine 2 theta over 2. Okay? So why do we call this a reduction identity? You can take a sine squared and reduce it down to a linear cosine term. Okay, so it reduces the power from squared to linear. Very useful in Calculus 2 when dealing with trigonometric integrals. The other reduction identities, well, say you take cosine 2 theta, and I have, what's the other one? It's 2 cosine squared theta minus 1, right? So add 1 to both sides. You get cosine 2 theta plus 1 equals 2 cosine squared theta. Divide by 2 on both sides, and so you have cosine squared theta equals 1 plus cosine 2 theta, okay, over 2. And so this is the other reduction identity. So those two are the most used. You can put them together to get tan squared, because remember, if tan squared theta is sine squared theta over cosine squared theta, right? So that's 1 minus cosine 2 theta divided by 2 divided by 1 plus cosine 2 theta divided by 2. And if you reduce this, you get 1 minus cosine, cosine 2 theta over 1 plus cosine 2 theta. So that is the tan squared identity. So I'm going to copy that real quick. So that's the last of the three reduction identities that we need. All right, so no need to memorize those. If you can memorize the double angles, then you can derive the others. Truly, the only double angles that I memorize, I absolutely, for Calculus 2, you use these all day. You need to know cosine 2 theta is cosine squared theta minus sine squared theta. Okay, and then you can get these two from that. The other one you got to know, if you're going to take calculus, you need to know sine 2 theta is 2 sine theta cosine theta. I mean, you just have to know these, all right? You got to know them. All right. Should we do an example? Yeah, I mean, we can do that. We'll do an example with that. Let me make sure. Okay, yeah. Let's do an example. Okay, so write an equivalent expression for cosine to the fourth theta that does not involve any powers of sine or cosine greater than 1. Okay, so we're going to use reduction identity. Okay, so this is actually a problem that you do in Cal 2, so they're kind of getting you ready for this. All right, so cosine to the fourth theta, right? Well, what does the reduction identity say? Well, it says cosine squared theta equals 1 plus cosine 2 theta over 2, right? But we don't have cosine squared, we have cosine to the fourth. So how do we rewrite cosine to the fourth as a squared? Well, if I do cosine squared raised to the 2, power to a power gets me to the fourth. So that's exactly what I do there. So I take this and now I substitute in everywhere I see cosine squared, I put 1 plus cosine 2 theta over 2. And since I'm multiplying it out, I'm squaring it, I'm going to multiply it out twice. Okay? So when I multiply this out in the denominator, I just have 4. In the numerator, I'm going to have to FOIL, so double distribute. And you get 1 times 1 is 1. 1 times cosine 2 theta. And then 1 times cosine 2 theta. And then cosine 2 theta times cosine 2 theta is cosine squared 2 theta. You don't multiply the arguments, just keep them there. And then I have 2 of these in the middle. So I have 1 plus 2 cosine 2 theta plus cosine squared 2 theta all over 4. And everything now is cosines that have power greater than, that don't have powers that are greater than 1. Okay? So, except this piece right here. So this one, we've got to do what to it? Well, I can replace this again with a reduction identity. So if I divide through, I have 1/4 plus, now 2 divided by 4, that gives me cosine 2 theta over 2. And then this is cosine squared 2 theta over 4. But I want this to be a linear term, so I'm going to replace it with this. So this piece right here, side work, this is going to be 1 plus cosine 2. And now look, this is very important here. This says the cosine squared of the angle is double whatever that angle is. Well, this is cosine 2 theta. Well, what goes in here is double the 2 theta. So I end up having to do 2 theta in here too. So I have two 2 thetas. So that's actually going to be a little bit bigger, right? So what does this end up being? It's 1 plus cosine of 4 theta over 2. But if I have over 2 and over 4, that gets me my 8 here. So that's what this piece right here equals. So it's 1/4 plus cosine 2 theta over 2 plus 1 over 8 plus cosine to the cosine of 4 theta over 8. Okay, so I can combine. I'm going to combine 1/4 and 1/8, and that's going to get me 3/8 plus 1/2 cosine 2 theta plus 1/8 cosine 4 theta. Now maybe I jumped too many steps to get from here to here, so let me talk about that one more time, okay, just to make sure we're good. So this is my final answer right here, by the way. But this would be, so cosine of blop equals 1 plus cosine of 2 blop over 2. Now the problem was my blop, so cosine squared of blop. Now what I had from my blop was cosine squared of 2 theta already in there, okay? So this is equal to 1 plus cosine of 2, and then my blop was 2 theta, okay? All over 2. So that's why I got the 1 plus cosine of 2 times 2 gets me 4. That's where that 4 came from. So hopefully that helps you. If not, just take a look at it a little bit more in detail later, and maybe it will start making sense for you. Okay. Let's do a couple more. Why not? We already made this a pretty long video. So, solving trigonometric equation using identities. Solve the equation sine theta cosine theta equals -1/2 for 0 to 2 pi. That's the interval. Okay. When I look at this makes me think of the sine double angle identity. Okay. How do I get there? I'm missing that 2 factor, so I'm going to multiply both sides by 2. So sine theta cosine theta equals -1/2. We'll multiply by 2 on both sides. And so I get 2 sine theta cosine theta equals -1. Now why did I do that? Because this is equal to the sine of 2 theta. Okay? So that's the double angle formula. The argument here is 2 theta. So writing the general formula that gives the solutions of the equation, and then list the ones that are in our interval 0 to 2 pi, Okay. So how do we get -1? When I plug in sine of something, I get -1. How do I do that? Think about a unit circle. The y value up here, it's 1. Over here, it's 0. Over there, it's 0. Down here, it's -1. So I need to rotate around 3 pi over 2. Okay? So what does that mean? I need for what's in here, okay? I need for what's in there, that 2 theta, I need it to equal, okay? I need this to equal 3 pi over 2, okay? Plus 2k pi, because if I rotate it, a full 2 pi, then I get back to my same angle. All right. So how do I handle this? How do I handle it? Well, I want a theta, so I need to divide by 2 on everything. Divide by 2, divide by 2. So I get theta equals 3 pi over 4 plus pi k. Okay. K is an integer. Remember that z represents integer. Okay? So pi k there is your integer. So in general solutions. Okay? Now, say I want it to be in the interval from 0 to 2 pi, right? So how does this happen? Well, if I plug in a 0 for k, if k equals 0, I get theta equals 3 pi over 4. That's in the interval. K equal to 1 gets me 3 pi over 4 plus pi, which is 7 pi over 4. Okay, if I do, that's in their interval. If I do k equal to 2, that gives me 3 pi over 4 plus 2 pi. Now, I know if I add 2 pi to it, that's going to be way outside. I mean, that's already outside the 2 pi. This didn't start at 0, right? So that's already out. And if I subtract pi from this, that's going to give me a negative number, so that'd be smaller than 0. So my two answers would be 3 pi over 4 and 7 pi over 4. Okay? So that would be my answer. My answers on this interval. Okay? One last problem for double angle. So this is a projectile motion problem. Okay, an object is propelled forward at an angle theta to the horizontal with an initial velocity of v0 feet per second. This figure, so they've got a little cannon. Oh my goodness, my cannon is not very good, but you get the picture, right? Pew! And it's going to hit this little target, right there, whatever. Okay? And so here's a little cannonball. How cute is that, right? Okay. And so this distance here, this is r. Okay, so r of theta is equal to 1 over 16 v0 squared sine theta cosine theta. Okay, so if the air resistance is ignored, the range r, so that's the range, the horizontal distance that the object travel is given by this right here. So this is the horizontal distance that the object travels. Okay? So we want to show that r theta equals 1 over 32 v naught squared sine 2 theta. Okay? Well, what do I need to have a sine 2 theta in there? Right now, this is what I have, right? I've got sine theta, cosine theta, right? So r of theta equals 1 over 16 v naught squared. Now, I'm missing a 2. If I had a 2 sine theta, cosine theta, I'd be done, right? So why don't I just put it in? But if I put in a 2, in order to not change the problem, I have to also put in a 1/2 so that those kind of balance each other out. 1/2 times 2 is still just 1. Okay? So now this becomes a sine of 2 theta, but I have this 1/2 and this 1/16 makes 1 over 32, and then my v naught squared stays the same, and that's what I want. Okay? So if you want something in there, you just put it in. Okay? Now the second part of the problem, part B, so this was part A, so part B says find the angle theta for which R is a maximum. Ooh, find the angle theta for which R is a maximum. So the angle is how the cannon is positioned, okay? So this angle theta is how the cannon is positioned. Now, in this form, the largest value for the R can be found for a fixed initial speed v naught. The angle theta of inclination to the horizontal determines the value of R. Okay? So if we had all this is, it's a fancy way of saying that R is a function of theta, meaning that we're not changing. So if we fix the speed, this is what it is. Okay? It's not changing at all. Okay? And the angle theta of inclination determines the horizontal distance value. So the largest value of sine function is 1. Okay? So if I use if I use my new form here that I found, I got 1 over 32 v naught squared, that's fixed, right? And then sine of 2 theta. Now, sine of stuff is stuck between -1 and 1. So what's the biggest? If I'm going to maximize this, I need to figure out how do I make this equal 1? How do I make that equal to 1? Okay, so what theta tells me that that's equal to 1? Well, sine is equal to 1 at pi over 2, angle of pi over 2. So if I have 2 theta equals pi over 2, if I divide by 2, I get theta equals pi over 4. So the angle is pi over 4. So the inclination, pi over 4, is like 45-degree angle, which kind of makes sense, a 45-degree angle like this. So that's going to maximize, that angle theta is going to maximize that cannon, the distance r traveled, okay? So the inclination to the horizontal of 45 degrees results in the maximum range there. So 45 degrees, or pi over 4, that is the optimal range to shoot your little projectile motion. All right.